Okay, Mr. Lombardo took his two children to a water park. He used the coupon shown below to buy one adult ticket. The price of admission for all three of them was $76. We want to find the price for the kids' ticket. Okay, so this is going to be an equation. He's going to use this coupon. He's going to go, what ticket price do we know? We know the adult ticket. And how much is the adult ticket?
28.
The adult ticket is 28. Good. I'm going to write this over here. How can we find the price of the kids' tickets? What would you do? How would you set this up? This is a word problem, and we want to actually set it up to be an equation. So what's our thought? Where could I begin? Now, I know I said write an equation, but there may be a way to do this without an equation. What do you think, Kevin?
Subtract 76 out of 28.
Okay, so Kevin's like, I know the total 76. I'm going to take 28 away. Why are you taking 28 away there?
That's how many is
Because you know that that's the price of the adult ticket. What are you left with? Sorry about that. What are you left with?
48.
48. Okay, and then what is that 48 in words? What does that 48 represent?
The two.
The two kids' tickets. Because in the problem, it tells us he's only going with three people, including himself. One is him, the adult, and the other two are kids. So that 48 makes up the two kids' tickets, which means how much is each kid's ticket? $24. Okay, so each one is 24. So we can do this, we already did this, but let's go over here. We can actually set up an equation. Some of you do this using arithmetic in your heads. We will get to a point with some of our equations where in your head may get a little challenging. So we still want to be able to explain it in an equation. So here's what we know. We know the price of an adult ticket is 28. We know he has two kids. We do not know the price of the kids' ticket, but we know the total. So if you had to explain this, how do we come up with our total? It's the one adult ticket plus the two kids' tickets would give me my total. And I didn't really say that in mathy. I just said the adult ticket, I used the word plus, but the adult ticket and the two kids' tickets combined would be 78.6. Okay? So now if I had this set up as an equation, 28 plus 2p equals 76. How would you solve if you were just told to solve the equation 28 plus 2p equals 76?
2p is the same thing, you're just multiplying.
Good. So then how would I solve the equation? What would be, if you saw that and you didn't have a scenario, you didn't know it was a park ticket or anything, you were just told 28 plus 2p equals 76, solve it. What would you do?
I would subtract 28.
You'd take 28 away from both sides, good. And you'd be left with 2p equals 48. And then what would we do?
We divide that by 2, so we can get
Divide both sides by 2. So p equals 24. How is that different than what Kevin did? How is that different than what Kevin did? Kevin, explain again what you did. What did you do to solve?
I subtracted the price of the adult ticket to the total.
He took away the adult ticket from the total. He did 28 minus 76, and then what?
And then the answer I divided by 2.
And then he took that 48 and cut it in half. How is what we just did different?
It's not different.
It's not different. It's actually not different at all. The only reason it's different is because our way involves algebra, because we utilized an unknown variable. Right? His way was just arithmetic. He subtracted and divided. It didn't involve any unknowns because he didn't need to create them. Explain what's happening to 3y in this equation. 3y plus 6 equals 30. What are we doing? What are we doing to y? Easy. We're multiplying by 3, and then
Get it by itself.
We're not solving it, we're just identifying what's happening to it. And then we're gonna add 6. So to undo that, we begin by taking the 6 away. Right? But let's go back. Let's say somebody comes in here and they're like, well, I know I'm multiplying by 3 and I know I'm adding 6, so I'm gonna do this. What's wrong? I mean, I divided both sides by 3, and then I subtracted 6 from both sides. So what is wrong? Why is my answer not 4? This is a big one, so whoever explains it, you have a lot of weight on your shoulders, because we got to explain this really, really well. Mortimer, go ahead.
Is it following not the right order?
But how do I know the order? Like, is there a specific order?
I think.
You may think. Okay, so for you, in your mind, there is a specific order.
I would do, to see if my answer's right, I would substitute 4 and 5.
Okay, so if you did that, you can come out here and just resubstitute y and put 4. If I do that, what's going to happen? Let's say I plug y, I plug 4 in for y. I'd end up having 12 plus 6 equals 30. 18 equals 30. What's wrong here? Do I know it's wrong? Yeah, the only way it would be right is if both sides were actually the same. But what if a student did that on a test? What would I have to say? How could I explain that that's not right? Because here's what a student's going to say. Well, you told me to identify the operations, so I did. I know that x is being multiplied by y, and I know we're adding 6. So I divided both sides, or I know that y is being multiplied by 3, and we're adding 6. So I did the inverse. I divided by 3, and I subtracted 6. That's exactly what I was supposed to do. Are they wrong when they say that?
No.
They're not really wrong, right? Because all we talk about is identify what's happening, inverse operations. But what is the key that the student did wrong? Because that is not the correct answer. There is a mistake.
You're not allowed to divide y divided by 3.
I'm not allowed.
I mean, you are allowed to, but like it's not really. All right, so what I'm trying to say here is like, you know how you use the one before.
Uh-huh.
You use 28, and the opposite is 28.
Mhm.
And those is like they're not equal, but like
The inverses become 0, right, when I do the opposite.
and see like I guess because the 3 doesn't have a y or whatever, like they're not equal, you can't really like do that.
But here, if I see that y is multiplying by 3, I'm not 100% wrong in dividing by 3, because that is the inverse.
In these types of problems, you're supposed to get the variable by itself first before you do the division.
Okay, but I did get the variable by itself. I got y is 4. Variable's alone.
But like it's all like the variable is by itself on one side of the equation.
But this is the only point that the variable is by itself. Because here it's not alone. This is one of those things where you're like, we know how to solve an equation. And I know that you know how to solve an equation. But this is like understanding the equation. Because what's going to happen is some of you have probably made this mistake on a test. Right? And I'm not going to tell you that there's a rule that you need to always add or subtract first. Because there's not a rule. But we need to identify why that's wrong. If you have an idea, it's okay to be wrong here. You've never learned why this is wrong. So any idea we can go with.
Could it be because of PEMDAS? Like, you have to like do the addition and subtraction first, and then.
You don't have to. So it's actually not. Now for you, like when I solve equations, I always do the addition and subtraction first. That's just how I do it. You don't have to though.
I don't really know how to explain it, but I do already know like where it went wrong
Where'd they go wrong?
because they did 30 divided by 3 first, but I know you don't have to do it in order, but it was like sometimes sometimes it will be easier to do it over like 6 divided by 30.
I totally agree with you. I think that subtracting the 6 is easier, right? However, it's not required. You don't have to subtract 6 first. I could divide first if I wanted, but there's a key mistake, and I need you to look at what operations we did and see where we potentially went wrong. Giselle, what do you think?
Is it the y?
What about the y? Two things were happening to y in this problem. It was being multiplied by 3, and we were adding 6. So what we did, we divided by 3 and we subtracted 6. We are right here. Yes or no? Yes or no? We're right. We did both things. We did the opposite. We're good.
I would say if you're dividing by 3, you should divide everything.
Explain further.
So if you, instead of just leaving the 6, you divide the 6 by 3.
You can absolutely divide first, but understand what you were taught and what you know. Whatever you do to one side, you do to the other side. You're not just in that scenario, if you don't remove the 6, if you don't take the 6 away, it is still on this side. Which means if your first option here was to divide, you divide the whole side by 3 and the other side by 3, which would give you y plus 2 equals 10. Now how do I solve? Now it's the only other thing I need to do to get y alone. Leo.
Divide 10 and 2 by 2. So 2. 10. Stop.
What's happening to y right here?
It's being added to 2.
Right here, y, we're adding 2. So the last thing I do is subtract the 2. So y is 8. Like, let's go back here and do what we would have normally started with. Minus 6, 3y equals 24. Then we could have divided by 3. Y equals 8. See that? I understand that most of you would start, like, for students that really struggle, I eventually get to where I say, do what's like not directly affecting the variable first, and then you can break down the variable itself. But either way is right. Like as long as you're attacking those inverse operations, the key is if you choose to divide first, you can't just divide the y. You have to divide the whole side. And sometimes that works out really well, like in this scenario, and other times it doesn't work out well. Like if the 6 was a 7, like I may not have wanted to do 7 divided by 3 because I'm looking at that, no, it's not going to be a whole number, and if I don't need to work with fractions, I don't want to work with fractions. Do you see the difference? That's something you've probably never really talked about before, but that's a key thing because as you get into variables on both sides, you may run into scenarios like this where you're not sure what to start with. Okay. You know what? Let's do, how are we on time? We're running a little low. So we're not going to use our whiteboards right now. One last time, we're going to talk about what's happening and how we're going to undo that. What is happening to x? What's someone else? What's happening to x? What's occurring here? Dave. Well, we're multiplying by. What's happening to this variable? 2 things. We're multiplying by 4, and then we're taking 2 away. So how can we undo that? Inverse operations. Undo that.
And we could add 2.
You could start by adding 2 to both sides. And then divide by 4. Good. X equals 6. Now this may be one of those scenarios that maybe a student says, you know what, I'm going to divide both sides by 4 first. Why would you not divide both sides by 4 first? It's not wrong, but your personal preference. Why would you choose not to divide both sides by 4?
Because you get a
Yeah, then you're turning this number, which is a beautiful integer, into a fraction. And then the same thing, because 22 divided by 4 would give me a fraction. You would still get the right answer if you worked the whole problem through, but a lot of us would try to avoid working with fractions if we can. Okay, we're going to just walk through an example here using a fraction. Hold on. Where are we here? I don't want to go through the whole thing. Different or the same as everything we've done? Different problem or same type? Well, let's say different type of problem or same type of problem? Same. What's the only difference? What is a fraction now? What part of the equation is a fraction? Now we're talking about vocabulary. What part of that equation is a fraction? I heard someone start saying. The coefficient, absolutely. Our equations, we have our variable, we have our coefficient, and we have our constants. So our coefficient is a fraction. Is that a problem? No, it's not a problem because we know how to do operations with fractions. What's happening to x? We're multiplying it by a fraction. What fraction specifically? We're multiplying it by 2/3 and then we're adding 1. So how can I undo that operation or that process? Marco. I can subtract 1 from both sides. And what am I left with? 2/3 x equals 4. 5 minus 1. Good. Now what?
We multiply both sides by 3/2.
Okay, so you jumped a step, but you're correct. In order to get that variable alone, if I'm multiplying it by 2/3, what should I do? What's the inverse of multiplying by 2/3? Dividing by.
Wait, no, not 3 seconds.
What's the opposite of multiplying by 2/3?
Dividing by 3/2.
Be careful what you're doing.
I mean,
So the opposite of multiplying by 2/3 is just dividing by 2/3, right? If I divide by 2/3, this would be by itself. Why would the x now have a coefficient of 1? What's any number divided by itself? No matter if it's a decimal, a fraction, or an integer.
1.
A 1. So 2/3 divided by 2/3 is 1. So now I'm left with x. Now on this side, I need to do a little bit of work. I have 4. I use fractions a lot to represent division when I'm dealing with equations, but we're going to switch that. 4 divided by 2/3. Knowing what we know about fractions, how would I divide 4 divided by 2/3? Manny. Only because you said it already.
4 times 3/2.
Dividing by a fraction is the same as multiplying by its reciprocal. So notice that now we took the idea of solving an equation and we threw in one little wrinkle, something that you've learned prior that we want to pull back in. 4 times 3/2 is what? Go ahead, Leo. 12 over 2, which simplifies as 6. It's a weird equal sign, curved. Questions. The process of solving an equation is no different when there's a fraction involved. We just have to remember the operation with a fraction. And I really don't want, which the reason we'll do fractions as often as we can, I don't want the reason that you're not getting 4s to be because you're messing up the calculation of the fraction. I would rather you not get a 4 because you're still a little fuzzy on the solving of the equation, like what we're working on right now. So we will always try to practice as often as we can with fractions. If we do something in class that you feel really confident with, consider doing challenging things that you're prepared for at home. And we'll talk about homework towards the end of class. Okay, so here's your DOL. Do this on a whiteboard. So everybody grab one. I know I already took your DOL sheet. Do this on a whiteboard.